Let's begin graphing square root functions. And let's start off with the parent. Every function has a parent. So the parent of a square root is f of x equals the square root of x. So let's work on building our table for that. So we have our x, then we're going to take the square root of that number to find our output. To avoid decimals, I am going to use x values that are perfect squares. And the first four perfect squares are 0, 1, 4, and 9. This is the first function in which the x values will not include negatives. And let's figure out why that would be. If we attempt to take the square root of a negative in your calculator, it is going to say non-real. It could say imaginary, or it could simply say that it's an error. And the reason why is because you cannot take the square root of a negative. So the x values, the lowest x value that we can use is 0, because 0 is the smallest number that we can take the square root of. So let's start off by taking the square root of 0. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. So let's graph these points. So when we look at this graph, notice that it has a start but no end. It begins at the point 0, 0, but x continues towards positive infinity forever. Therefore, our domain is going to begin at 0 and end in infinity. Infinity always gets a parentheses, but 0 is actually included, so we're going to put a bracket on that. The range, when we look at our y values, it also begins at 0. Because it's impossible to take a square root of a number that is less than 0, our output is also going to be 0 for the parent. So when we write our range in interval notation, we have the square root of 0 to infinity. This is the parent table that we're going to use for the rest of the examples. So let's look at example 1. So this example, this is our function, and this is the transformation form of a square root. And notice we have a new friend, b. We'll talk about b a little bit later. A will be found in front of the square root. It is still going to vertically stretch and compress your graph and reflect it across the x-axis. H is underneath the square root, and it moves your graph left and right. K is on the outside of the square root, and it's going to move your graph up and down. So let's begin with our parent. From the previous example, we derived the table for the parent of y equals x squared. So these are the points that we're going to transform. When we look at this equation, a is equal to 2. H is equal to the opposite, so negative 3. And K equals negative 1. So what changes do we expect to see? Well, because a is equal to 2, we expect for it to vertically stretch. Also, because h is negative 3, we expect for this graph to move to the left 3. And because k is negative 1, we expect for it to move down 1. So we're going to take all of our x values, add the h value to it, but multiply our y values times a and add k. So when I add h is negative 3, I'm going to add negative 3 all the way down to all 4 of my x values. And when I do that, my new y values are transformed and they become negative 3, negative 2, positive 1, and positive 6. Now let's take our y values, multiply them by the a, and add k. Multiplying them by negative 2 and subtracting 1. And when we do that, we will see how our y values are transformed from the parent. So let's begin. 0 times 2 is 0, and 0 minus 1 is negative 1. 1 times 2 is 2, 2 minus 1 is 1. 2 times 2 is 4, 4 minus 1 is 3. 3 times 2 is 6, and 6 minus 1 is 5. So when I graph this function doesn't begin at 0, 0. It begins at negative 3, negative 1. So negative 2, positive 1, up 3, and 6 up 5. This is what this transform function looks like. I'm going to quickly graph the parent as a comparison. And if you look at it, this red graph is the parent. If you compare the black graph to the red graph, you can see that it is vertically stretched because it is being pulled up. It moved to the left 3, and it also moved down 1. So when I'm looking at my x values, my new lowest number is negative 3. This function is going to begin at x equals negative 3 and then increase towards infinity. So we have bracket negative 3 to infinity. But our y values start at negative 1. So our range will be negative 1 to infinity. Let's do one more example. Okay, so when we're looking at this example, again, notice that we have our a value, which is found in front. So in this example, a is equal to negative 1. The h value is underneath the square root, but it's the opposite, so h is positive 2. My k value is on the outside, and that's a positive 5. So because a is negative 1, it is going to reflect. In the second video, we'll talk about why it's important to emphasize that it reflects across the x-axis. But for this function especially, you do need to specify what axis it is reflecting across. And when a is negative, it reflects it across the x-axis. And that's really important to note. Because h is 2, this graph is going to move to the right 2. And because k is 5, it will move up 5. So, for comparison purposes, I am going to graph the parent again using that parent table that we began with. 0, 0, 1, 1, 4, 2, and 9, 3. So using that, this is our parent, and we're going to compare how, we already know how it's going to be different, but we're going to graph this function, and this function is going to be different from the parent because it's going to reflect across the x-axis, it's going to move to the right 2 and up 5. So let's put down our parent table. So the parent table, we begin with the 0, 1, 4, 9, 0, 1, 2, 3. So I am going to take my h value, which is 2, and add it to all of my x values to get my new transform domain. So when I do that, I get positive 2, positive 3, positive 6, and positive 11. And now let's do the same thing with our y values. So we're going to take our y values, multiply them by our a, and then we're going to add 5. So let's take these 4 numbers and multiply them by -1 and add 5. So when I do that, I get +5, +4, +3, and +2. So now we are ready to graph our 4 points for our transformation. So when I graph it, I'm beginning at 2, 5. And then from 2, 5, we have 3, 4, 6, 3. And then our last point is just off our grid at 11, 2. Okay, so we're going to connect it, and it's going to look different because this is flipped upside down. Okay, notice how this graph is upside down. I like to think of a square root as an eyebrow. If you look at the parent, it looks like an eyebrow. This is an upside down eyebrow, and it's upside down because our a value is negative. So what would our domain be? Well, when I'm looking at my graph, I'm noticing that on the x-axis it's beginning at 2, but then all the other numbers are greater than 2. You can also look at your table and see that your x values begin at 2 and they get larger. So that means that my domain is 2 to infinity. Now let's look at our range. Our range starts at 5, but in this example they're getting smaller. So because they're getting smaller, and keeping in mind that interval notation we start with the smallest number, that means that it's coming from -infinity and stopping at 5. So my domain is -infinity to 5.